Introduction. Implement methods to learn useful data representations without explicit labels, enabling downstream tasks with minimal supervision. Welcome to this session where you will learn how to develop representation learning approaches using unsupervised learning techniques. These methods help your models understand data without needing labeled examples. Understanding unsupervised learning. Unlike supervised learning, unsupervised learning works within labeled data. The goal is to discover hidden patterns, structures, or features within the data. This approach is useful when labeling data is expensive or impractical. What is representation learning? Representation learning focuses on transforming raw data into meaningful, compact features. These representations capture important information that helps with tasks like clustering, anomaly detection, or as input for other models. Why representation learning matters? Good representations reduce data complexity and improve model performance. They enable models to generalize better and learn efficiently from fewer labeled examples, saving time and resources. Common methods for representation learning. Techniques include autoencoders, principal component analysis, and contrastive learning. Each method aims to learn features that represent the essence of the input data in a lower dimensional space. Building representation learning models step by step. Begin by selecting an appropriate method based on your data and problem. Next, train the model on raw data to learn the representation. Finally, evaluate the learned features on downstream tasks such as classification or clustering. Applying representation learning in practice. For example, in image analysis, autoencoders can learn compressed features that preserve important visual information. In text processing, embeddings capture semantic meaning without needing labeled datasets. Benefits of minimal supervision. Representation learning reduces dependency on large labeled datasets. This is especially valuable in domains where labels are scarce or costly, like healthcare or security. Validating learned representations. Assess the quality of representations by measuring performance on related tasks. Use metrics such as clustering accuracy or downstream classification accuracy to validate usefulness. Iterative improvement and refinement. Experiment with different model architectures and hyperparameters to enhance feature quality. Incorporate domain knowledge to guide model design and interpretation. Challenges in representation learning. Unsupervised methods can sometimes capture noise or irrelevant patterns. Careful tuning and validation are necessary to ensure meaningful representations. Reflecting on your projects. Think about tasks where labeled data was limited. How could representation learning have helped extract useful information? Identifying such opportunities can boost your model development. Best practices for developing representations. Choose methods aligned with your data type and scale. Use visualization tools to understand learned features. Combine unsupervised learning with semi-supervised or supervised methods when possible. Tips for crafting clear prompts with Gen AI. Ask for specific techniques or model suggestions. For example, say, suggest an autoencoder architecture for learning representations from sensor data. Clear prompts help generate precise guidance. Conclusion. Developing representation learning approaches with unsupervised learning unlocks powerful ways to extract meaningful features without labels. These methods enable efficient downstream tasks and reduce labeling effort. Thank you for joining this session. Start applying these techniques to make better use of your unlabeled data and improve your AI models.